Good morning, everyone. My name is Jeremy Jam, and I'm from Good 2, and this is our mid presentation of our project design for EE Field 70. So you can see in the left-hand side, this is the ESP8266. What is this? This is a Wi-Fi module we were going to use for our PVA design. And for the for the right hand side, you can see is the ESP32 cam. So it is the Wi-Fi module with the camera feature in it. So we can insert the cam inside here, so we can have a Wi-Fi module. This Wi-Fi module combined with the cam, and also it come with the micro SD card, so we can install the image in here. So in here you can see on our left hand side, this is the previous design of our DC motor lock. So when the power supplied by the DC motor, it will lock the door. And it is AC currents, so in inverse it will unlock the door. So in the right hand side you can see it is electric lock assembling solenoid. So what it does, when the current passing through the lock, it will generate the magnetic fields that pull out the locks, which is unlocking the door. When there's no current passing through, it will pull out and it will lock the door. It will save us a lot of time in our circuit design. Just insert it into the right signal. This is what we hope we can do in our final product. So you can see in here, the left hand side, this is what we hope the user can see on their cell phone, which direct from the live stream from our camera on the ESP32 cam. And we hope our user can use the cell phone to unlock or lock the door. So what is the special feature of it? Thanks to the ESP32 cam, we can do the real-time stream for this project, as we can build the video streaming server by accessing the IP address of the camera, which is quite easy. So also we will come with the warning message, and what it says is when we pressing the doorbell, or in here is the switch, it will send a message to you, and so you can click on the app and you can see the video on it, and you can determine whether or not you want to call the emergency service. So here is our system budget. So since we have changed a lot of aspects in here from our previous design, so it will save us a lot of money. For the previous design, in total we're going to need roughly around $790. For the new design, since the Juno bought, we are borrowing from our E department, so it's going to be free. The ESP32 cam will be roughly around 100, and the electric lock will be $50. And then we're going to need a relay for it, so we're going to be extra $50. And for the power bank, we're going to use is what's commonly used for charging our cell phone, which have a quite around 12 volt. I'm going to use a 5 volt. Will be $150. So in total will be $350. So here is our schedule from our previous. This is our previous schedule. For week 1 to 3, we do the confirmation of the function specification, system architecture, definition of word and pen. And for week 1 to 6, we're going to do a hardware and software design. For week 7 to 10, we're going to do the integration of the design, IoT application platform design. For week 8 to 11, we do the system fabrication and implementation. For week 10 to 12, we're going to do a testing. Week 8 to 12, system debugging. Week 12 to 15, we're going to do a report writing. Here's the milestone we achieved. We do the confirmation of function specifications, system architecture, definition of word and pen, complete the basic circuit design for connecting Arduino and the ESP32 cam, and integrate the design. Here's the future plan. Our plan in the upcoming week is to wait for the delivery of hardware so we could implement our design. We're going to use the simulator to do some field testing until the ESP32 cam is delivered. We will set up the Wi-Fi connection between the Arduino and smartphone and design the software that could control the Arduino. Here's the conclusion, where we pay some of the field function and keep improving our design, and it was quite challenging for a group of 2 to complete the project instead of 3. So here is our Q&A session, and this is the end of our presentation. Thank you.